Hello everyone, my name is Robbie Milner and I am a PhD student at Ohio State University under Dr. Ayman Fayed in the Power Management Research Lab. For CYAN, we are working on task 1.3, securing power supplies against power side channel attacks. Other students working on this project were Tanner Tengberg, a PhD student who graduated a couple of years ago, and John Spiesmaker, a master's student who graduated this past spring. For our project, we have done the design of a DF-SIMO butt converter with spur-free switching. For some background, a butt converter is a switching power converter that takes an unregulated input voltage source that is capable of driving high amounts of current and producing a controlled, approximately DC output voltage that stays around the controlled voltage regardless of load current. A DF-SIMO butt converter stands for dual frequency, single inductor, multiple output butt converter. So with one inductor, we have multiple outputs that are integrated on the same chip, and the capacitors for them are integrated on chip as well. The main security concern for power supplies is that the spectrums of the power supplies can contain information about the circuit being powered if probed. For example, if this circuit were powering an advanced encryption standard circuit, then spurs from that circuit could leak through into the power supply, and those spurs could potentially be probed and used to reveal information about the encryption standard, thus being a security threat. Our goal with our research is to find a way to obscure that spectrum to hide any information that could potentially be probed, whether through physically probing or through emissions. To do that, it can be done theoretically by varying the clock frequencies around a controlled value to spread those spurs out and effectively obscure the spectrum. We do this using a circuit that uses controlled clock frequency hopping, where we have a voltage ramp feeding into a comparator that generates the clock signal. The voltage ramp is being fed by a combination of current sources that are connected to a pseudo-random number generator, which is used to effectively vary the amount of current going into that voltage ramp each cycle, and thus effectively varying the frequency of the clock each cycle. It is controlled around a range so that the converter can still operate around its normal clock frequency, but you can see in the spectrum to the bottom right in the result, when we do scramble the frequency around this range, it effectively spreads those spurs out and effectively raises the noise floor of the spectrum so that any spurs from the circuit connected to it would be invisible to anybody probing.